We're now cycling back around and going into graphing when everything's in standard form, when we can do some of our other more advanced factoring techniques, including factoring by grouping and synthetic division and things like that. So we're going to graph in standard form today. Find all the requested information and graph f of x equals negative x to the fifth plus 3x to the fourth plus 9x cubed minus 27x squared. The first thing I'm going to notice is that there is a greatest common factor. I'm going to factor out a negative x squared. So I end up with x cubed minus 3x squared minus 9x plus 27 after I factor that out. Then I notice that if I group these two terms and I write, I factor out the greatest common factor of each of those terms. The greatest common factor of the first one is x squared. The greatest common factor of the second one is negative 9. And when I look at those two things, both of them would be left with x minus 3. So one more time, just a reminder, if I have x cubed minus 3x squared and I group those two terms, I have x squared times x minus 3. And then I have minus 9x plus 27. And I pull out a negative 9. And I'm left with x minus 3. I can then factor out x minus 3. And what's left is x squared minus 9. And if I redistributed this, I would end up with x cubed minus 3x squared minus 9x plus 27. So that's just a reminder on why factoring by grouping works. So now after I see that, I can factor the x squared minus 9, and I can have the final factored form of this. So negative x squared, x minus 3, x plus 3, and then notice I had another x minus 3, so I can actually write this as x minus 3 squared, because I get an x minus 3 from the x squared minus 9, and then I also had the x minus 3 that I already have. So my roots are at 0, 0, 3, 0, and negative 3, 0. And what we will notice is that 0, 0, and 3, 0 are going to be double roots. So 0, 0, 3, 0, and negative 3, 0 are going to be my roots. I'm going to have double roots at 0, 0, and 3, 0. And then my y-intercept is at 0, 0. I don't have a maximum or a minimum globally on this function because the power or the degree is 5. So that means it's going to go in opposite directions. And then since I know it's a negative x to the fifth, that means that as x approaches negative infinity, I should know that f of x approaches infinity, and vice versa. As x approaches positive infinity, the function will approach negative infinity, the y values will. So it should look something like this as I end. And then since 0 and 3 are double roots, I'm going to cross at negative 3, bounce at 0, and bounce at 3. And that will be what my graph looks like. Second problem. Find all requested information. So in this case, there's no easy way to factor by grouping, so I'm going to, I don't have any greatest common factors or anything. So what I have to do in this problem is do long division or synthetic division. I'm going to do synthetic division. I'll choose 1 as a possibility. So 1, negative 2, negative 5, 6. By the way, I'm just going to remind myself by the rational root theorem that I take the coefficients of the first and last term. I put plus or minus all of the factors of the last term divided by all of the factors of the first term. Since the first term, the first coefficient is only 1, that means that my possible factors, my possible roots that work that are rational are 1, 2, 3, and 6, and the negatives of those. So that's just a reminder on that. So I'm going to try 1. I usually try 1 or -1 first, so it's a little bit easier. So I pull down this 1. 1 times 1 is 1. -2 plus 1 is -1. 1 times -1 is -1. -5 minus -1 is -6. 1 times -6 is -6. And then 6 minus 6 is 0. The good news, once again, is anytime I get 0 as my remainder, then the term that I picked, or the number that I picked here, is a root, which means that the factor x minus 1 works in this function. So f of x equals x minus 1, and then this will be the x squared term now. This will be the x term, and this will be the constant term, as everything subtracts 1 from the power that we currently have. So this becomes x squared minus x minus 6, and x squared minus x minus 6 is easily factorable as a trinomial. So I have x minus 1 and then the product of two binomials, x minus 3, x plus 2. So those are my factors. My roots are at 1, 0, 3, 0, and -2, 0. All of them are single roots, so they cross everywhere. My y-intercept is at 0, 6. I'll make this point 0, 6. I'll go up by 2s, I guess. And then I'm not going to have a minimum or a maximum because, once again, this is an odd degree, so that means they're going to go in opposite directions. And since the leading coefficient was positive, as x approaches -infinity, the function goes to -infinity, and as x approaches infinity, the function goes to infinity. So I can, or I should be able to graph this now. So I know 1, 0, -2, 0, and 3, 0 are roots. I know that the function will look something like this with its end behavior, and then the function will look something like that because it crosses at all of the roots. Third problem. If I take a look at -x to the fourth plus 9x squared plus 4x minus 12, I can do the rational root theorem once again. So plus or minus 1, 2, 3, 4, 6, and 12 all over 1 are all of my potential roots. I would usually start at 1 and -1, 2 and -2 before I start doing anything big because the synthetic division gets kind of nasty. I wanted to show one case down here where this didn't work before I started, just to remind us that not every time that you pick a number, it's going to work. So notice that -8 didn't work, which is kind of sad. So I'm going, or I'm sorry, -8 is not 0, so that didn't work. So -1 was not a factor, or I'm sorry, -1 was not a root of this. So I will try 1. So if I try 1, 1, I'm sorry, -1, 0, 9, 4, and 12. Just a reminder that I need to put the 0 in for the x cubed term because there is no x cubed term that's visible. I will pull down the -1, and then oh, I'm sorry, that was supposed to be a -12. I was wondering why that didn't look like it was going to work. So because I have a 0 for my remainder, that means that that is a factor. So I can partially factor this at the moment. So I have x minus 1 times -x cubed minus x squared plus 8x plus 12. What we will notice is that this, once again, I can't easily factor or do any grouping of any sort. So I'm going to try some other things. I'll try 1 again. I already know that -1 won't work because I already tried -1 down here. So I'll try 1 again, and then when I try it again, I'll do it on what's left over. So -1, -1, 8, and 12. If I pull down the -1, I get 0, 0, 8, 8. That's 20. 20 is definitely not 0. So that means that -1, or I'm sorry, 1 does not work a second time. So I guess I need to try something different. I'll move on to 2, or in this case, to save some time, I will move on to -2, because spoiler alert, -2 works. So -1 times -2 is 2. 1 times -2 is -2. 6 times -2 is -12. And then I end up with 0, which is a good remainder to have if I'm doing a problem like this. So I can factor this into x minus 1, which is already here, x plus 2, and then I have -x squared plus x plus 6. In order to easily factor the -x squared plus x plus 6, I'm going to rewrite this as f of x equals -x minus 1, x plus 2, x squared minus x minus 6 by just factoring out a negative from that, that trinomial. So I have that. And then I can factor x squared minus x minus 6 the exact same way as I did in the previous problem. So I have -x minus 1, x plus 2, x minus 3, x plus 2, which might be better to write as x plus 2 squared, because I have two terms that are the same with these x plus 2's. I guess it didn't really want me to erase those little things. And I don't want you thinking they're plus or minus. So I guess it'll take 10 more seconds out of your life to watch me erase those things. So my roots are at 1, 0, -2, 0, and 3, 0. So those are my roots. My y-intercept is at 0, -12, which I can easily see from the original problem. I will have a maximum or a minimum in this case. I just have to figure out which way it's going in a minute. So I have -12. I'll just make that -12. So I guess the scale is now 4s. I have a root at 1, 0, a root at 3, 0, and a double root at -2, 0. Notice that my leading coefficient was negative, and I had an even power. So that means that f of x is going to go to -infinity in both directions. So my function will look like this. And then I have to make sure that I know what is going on. Well, I had a double root at -2, which is good because I have to somehow hit this point. Then there's a single root and another single root. So this is kind of what the graph will look like. That means I have a maximum on this function. I will not have a minimum on this function because it goes to -infinity in both directions. So if I quickly look at the graph, I'm not going to use the TI just for time purposes, but if I quickly look at the graph and I see -x to the 4th plus 9x squared plus 4x minus 12, I see that my maximum is at 2.225, 16.947. So as I go back and I write that down, I have the maximum at 2.225, 16.947. And then there is no minimum. Okay, last problem. Well, the first thing I'm going to do is I don't like this 1/4, so I'm going to factor out a 1/4. I get x to the 4th minus 9x squared minus 4x plus 12. If I take a close look at that and I look at the previous problem, if I factored out a negative at the beginning, would be x to the 4th minus 9x squared minus 4x plus 12. Well, those look really, really similar. So because those look really, really similar, what I'm going to do is this, I'm going to assume factors into the exact same things that the previous problem factored into. And I hope I'm going to be right on that. So the leading term that I factor out is now 1/4, but it's not -1. But I should end up with x minus 1, x plus 2 squared, and x minus 3. So my roots should still be at 1, 0. -2, 0 should still be a double root. And 3, 0 should still be a root. I should have a y-intercept at 0, 3. So that's not going to be at 0, -12 anymore. So 0, 3, I'll make this scale go up by ones. I have a double root at -2, have a root at 1, and a root at 3. And then I should have a minimum in this case. I should have no maximum, because notice that even though it's still x to the fourth, now my leading coefficient is positive. So the x to the fourth should result in a graph that looks something like this, where it's going up in both directions. Then I have the double root at 2. I have the single roots at 1 and 3, so it bounces at -2, and it crosses at 1 and 3. Then if I quickly, so notice if I recognize something that I already know, I don't really need to do all of the synthetic division and everything else anymore. So if I graph this one, I see that uh, it does still have roots at -2, 1, and 3, which is good. And then notice that my minimum is at the same x value that my maximum was. And I'm venturing a guess that the y value at -4.237, if you take the 16.947 and divide it by -4, or divide it by 4, you end up with -4.237. Again, we round to 3 decimal places here, but notice what happens is that since these are just, they have a values and then the factored a value all the way through. So since every single root is the same and the a value is the same, the graphs are actually mirror images of each other to an extent, where the blue graph is exactly the same as the red graph if you multiply the red graph by -1/4. And so notice that the maximum of the red graph and the minimum of the blue graph are at the same x values, and then the y values are just uh, multiples of 4, basically, of each other. And so I can finish the problem by writing the minimum of this at 2.225, comma, -4.237.